Good afternoon. Thank you very much for inviting me to Seoul, a beautiful city and beautiful weather. It's been about 18 years since I have last been in Seoul, and it's changed a lot. It's amazing how much the city has developed, and I hope tonight after the forum I have a chance to see some of the city and maybe have some great Korean food and some shopping. So thank you again, and thank you for coming this afternoon to hear some information from Red Hat about our work in containers. When I speak about this topic, I like to ask the audience for a show of their hands so that it helps me understand where you are in your journey with containers. So let me begin by asking you to respond to one of three questions. First, with containers, are you very much trying to learn and understand this technology? Show of hands for this. Or are you actually using the technology and doing early stage proof of concept or pilots? Show of hands. Or maybe you are actually using containers in production environments with production applications. So show of hands. Okay, so a mixture across all three categories, but I think most of you are either trying to learn or trying to do early work in this technology area. So hopefully what I will share with you will give you some insights. We'll first begin by talking about everything Red Hat is trying to do. And containers are very important because they fit across all of this. Containers will allow you to develop agile infrastructure that is very easy to adapt and change, but it will also extend into an area of microservices where we understand how applications can be connected into other capabilities using integration software or even onto mobile devices. And then finally, one of the most important themes for containers is how it allows for DevOps. And you'll hear me describe this as we get into the presentation today. So first, let me describe the problem that faces the IT organization. The IT organization is asked to be very responsive to the line of business. To do this, they have to deliver applications and then run those applications. The line of business makes changes and requests on a daily and weekly basis. And the complexity of these applications is also growing. So IT is stuck in a very difficult situation. Furthermore, within the IT organization, the teams traditionally have been very disconnected. The development and application team versus the infrastructure and operations team. They did not collaborate very well. In the US, we have a word called throw it over the wall. So when the application team finishes their application, they will throw the code over to the operations team and explain that they just want this put on a server and run. Sometimes they will describe a very detailed list of configuration requirements about the size of the server, the runtime libraries, and other tools that need to be included on the server to make that application run. So this list of complex requirements is very challenging. And again, the operations team and the development teams traditionally have not worked together very well. Each of these applications has different requirements. Some of these applications are written in Python or C++ or Java. They may have different runtime library dependencies. They may have different databases they use or other tools. All of these requirements have to be included on the operating system that the application runs on. Furthermore, when that application is supposed to be moved onto another server, or maybe you create additional copies of the application because now you run, instead of 5 versions of the application, you want to run 50. Every time you move this application onto a new server, you have to repeat the same configuration and collect the same requirements for this server. So all of this complexity is exploding, and it makes it very difficult for IT. Not only is this complexity for technology, but it is also complexity for the people, the skills, and the systems that support it. So this costs time and money. We believe containers are an important way for IT to improve the way they operate. These improvements will improve the development teams, and it will also improve the operations team. And we will talk about exactly how this works as I go into the presentation. Containers have a very strong language parallel in English to the shipping containers. You see what they look like here in the picture. And because of this, we like to use analogies from manufacturing to describe the concept of packaging, because in fact, that is what containers are all about. Containers are all about how you package together application code, tools, and the runtime libraries they depend on into an image format in a way that this container can now be more portable, it can be based on standards, and it can be used over and over again and shared. So this is the basic concept of containers. But because of this analogy to the shipping industry of containers, we talk about manufacturing and other analogies. And the analogy here is when you are building anything in packaging it together in a factory setting, you do not do this when you are about to load it at the dock of the ship or the truck. You want to package your manufactured goods in the factory with standards, with processes, and with skills. You don't want to load these just as you are about to put it onto the ship. So that's the simple analogy. But let me give you a couple of other analogies. First, one of the things containers does very nicely is it modularizes the application functionality into discrete components that can be reused, can be updated more easily, and also moved around. The thing I like to describe as well as an example is the automobile. The comparison to the automobile would be, imagine that you have an automobile that typically we like to use these cars for 5, 6, maybe 8 years. And when you want a new engine in your car, because the engine technology changes, you don't simply change the engine in the car you have. You have to wait until the car is replaced in 6 or 8 years. Similarly to the navigation and electronic systems, you can't simply update the system when you want, when there is a new navigation available. It is very difficult to do this. It can be done, but it is very difficult. You wait until you buy a new car. These are totally engineered, integrated systems, the car, and all of the components are very tightly coupled together. In the world of containers, the example would be if you wanted to get a new engine, you could interchange that component at any point. If you wanted to get a new suspension control system, you could interchange that component at any point. So this concept of modularity and componentizing allows you to create applications that are comprised of piece parts that can be treated differently. And I'll give you another example about this. Imagine you are an investment banking firm, and you create an application that your traders use to trade against commodities, options, or equities. This application may have been developed in your company 10 years ago and was done as a very tightly coupled integrated system. Because of this, changes to the pieces of this application are very difficult, just like I described with the car. This application I'm going to tell you about has 3 pieces. There is a front end that your traders use to interact with and place orders for the trades. There is a back end that accepts market data feeds for the currency exchanges and the prices of commodities that feed the system with prices and data. And there's a middle section that has your trading algorithms. These algorithms are the competitive advantage for your company, and they're very critical and very sophisticated. But each of those 3 components I described have different requirements as an application. The front end may need to scale as you hire new traders or as you have trade volumes increase. Scalability. The back end, with market data feeds, has requirements for high availability, because if those systems go down, your whole system shuts down. So high availability, number 2. And finally, number 3, the algorithms, the quantitative trading algorithms that you use, maybe you want to update those every day or maybe every 4 hours, because this is the critical thing that gives your firm competitive advantage. You want to maybe test 2 different algorithms against one another. So this middle section, the third requirement, is high frequency updates to the software. So all 3 of these components in this application have different requirements. In the traditional world of application development, it's very, very challenging to change any of this because they're all tied together. In the new world of containers, you can treat these individually and you can make changes to them or architect them differently because of that. So let's also ask the teams in IT what they think of as containers. If you ask the infrastructure team to describe what containers are, they will talk about them as components of the operating system. They will talk about it as Linux. They will recognize that Linux is used in the container, and it's also used on the host operating system to run the containers. So they'll think about that. They'll describe them as lightweight. They'll talk about the memory consumption, performance. They'll compare it to virtualization, because some aspects of containers are very similar to virtualization in the way they abstract the resources and also create higher density for your workloads. They'll also talk about the need for orchestration and management. If you ask your development teams what they think containers are, they'll talk about the ability to package the components together in an image, like I described. They'll talk about this concept of modularization of the architecture and how you can treat different pieces. You can reuse the code. You can share the code with other people. If you have a container that's been built for a certain function, like a web server, other people can easily use this. It will also describe, they will also describe the control that it gives them to package the dependencies into the container that they need. We conducted some research with Forrester, a leading IT analyst firm, and we asked customers what are some of the things they're seeing as the benefits and why would they use containers. If you look at the reasons cited, most of them deal with efficiency and speed and the ability to do things faster. We also asked the same respondents to talk about what are the things that give them challenges and slow them down with containers. The number 1 reason cited was security, but they also cited other things like scalability, performance, and how to manage the container environment. We will talk about all of these, because these now describe what we talk about as the requirements to do containers in the enterprise setting. It is very popular today for a developer to download the Docker tool and to put it on their laptop and to play with this technology. Many developers in your companies are probably doing this. But doing it on a developer laptop is very different than doing this on 50 or 100 or 1,000 servers running mission-critical workloads. So we will talk about some of these requirements. Some of them came directly from the research I mentioned, but this will lead to the work that Red Hat is doing. Things like security, how these containers are portable, how you manage them, and the need for a total solution. So let's begin by talking about security. Security is critical, but also comes across many different areas. First of all, the host system. The host operating system is still required to run a container. It still needs a Linux kernel and some of the other tools to do namespaces, resource management, and security. But these are still part of a host operating system. Red Hat has 2 versions of this today. We have Red Hat Enterprise Linux 7. We also have Red Hat Enterprise Linux Atomic Host. Both of these are host operating systems for containers. But underneath this, you still have to think about the operating system components, and how they are kept secure. One way is doing it with SE Linux. SE Linux stands for Security Enhanced Linux, and it's the technology that is used to isolate and wrap the host operating system and the containers and prevent access that is unauthorized. The content which is used in the container to build that image I described, as I mentioned, comes from the operating system. The runtime libraries, glibc, other things are pulled into the container as it is built, as an image. The container images are stored in repositories where developers and production people can access them. They can access the components that go into a container. They can also access the completed container. A very famous repository for containers is Docker Hub. And a year ago, more than 1 year ago, a company did a scan of almost 1,000 images in Docker Hub. And they found that 36% of these images contained high priority vulnerabilities. Vulnerabilities like Ghost, like Shell Shock, like Heartbleed. These were very significant Linux vulnerabilities that come from OpenSSL, Bash, glibc, very popular, highly used components of the Linux operating system that were in the containers and out of date with the vulnerability. So the message there is be careful of where you get your containers, make sure that you know who built them, are they up to date, and are they secure. Next, Red Hat has a security team whose mission in life is to work on identifying the vulnerabilities that I mentioned over here and over here. There are several dozen people in Red Hat, and that's all they do. They work with the upstream communities, and when they identify problems like Shell Shock, for an example, and often they're working with other companies like Google to do this, they will issue the fix and the patch to Shell Shock and make it available. This is their job, but this is important why a company like Red Hat stands behind this work and supports the complexity of dealing with containers technology. And finally, we have people in Red Hat who are on the engineering and development teams who are developing this technology in the upstream communities, like Docker, like Kubernetes, working with Docker Inc. and working with Google on these communities, but we have some of the most highly respected engineers working here who are now experts and can also make sure that their expertise gets applied to how we do security. Another example of security is the atomic scan technology that's included with our host operating systems. Atomic scan is effectively a scanning interface that allows you to scan the containers and perform deep container inspection against the vulnerabilities I mentioned. You can do this a few different ways. You can connect to OpenSCAP, which is the Open Security Content Automation Protocol. This is the default setting for Atomic Scan, but Atomic Scan also includes an open API, so you can connect into your favorite scanning technology. In this example, we are working with Black Duck and connect into their software scanning to do this function. Another piece I've touched on is the fact that the Linux operating system is used inextricably in containers. It's used as the host, but it's also the content that gets built into the container image. Linux is growing, and this year is now shipping more Linux than even Windows Server, and will continue to outship Windows moving into the future. So the OS matters. Red Hat is the leader in Linux, the most popular operating system in the world. The other thing that we will talk about is portability. Portability means that you do the work with standards onto a consistent platform, and you are therefore able to move the container onto different platforms. We use Red Hat Enterprise Linux as the foundation for all of our products, whether it is, I mentioned Red Hat Enterprise Linux Atomic Host, a container-optimized operating system, OpenStack Platform, our cloud scale infrastructure platform built on OpenStack, but built with Red Hat Enterprise Linux, And OpenShift, of course, our container platform, runs on RHEL. The use of RHEL as the foundation for all of this drives the portability across physical infrastructure. So operating system running on a physical server, virtualized environment where you have RHEL guests running on either Red Hat virtualization or VMware infrastructure, private clouds with OpenStack, or even public clouds with AWS, Azure from Microsoft, or Google. So as I mentioned, how do you do this at scale? Because doing this on one developer laptop is not the same as doing this on 100 or 1,000 servers. When you do this on 100 or 1,000 servers, you have to consider many other complexities. How do you manage the containers? How do you manage where they are, who has access to them, are they updated, are they secure, how long should they stay on a server before they are decommissioned, who has the authority to promote a container from a staging server into a production server. All of these things I just mentioned are associated with policy. Red Hat CloudForms allows you to manage container policy. We've enhanced CloudForms to do this recently, about 1 year ago. CloudForms, as a core product offering, is aimed for hybrid cloud management, managing across multi-vendor virtualized infrastructure and into public cloud. So it was designed and built to manage between VMware environments, Red Hat environments, and the public cloud. But now we've extended CloudForms to manage container policy and also container resource management. So across clusters of container hosts, what is the resource profile and availability for memory, storage, network, and compute, and where should containers be placed in order to load balance. This is what CloudForms does, but helps you do that container management that's needed to manage containers for the enterprise. You also have to look at and consider what else do you need beyond the host operating system. You need a full set of portfolio components to do not just the host, but to also do an integrated development lifecycle. This is where OpenShift Container Platform comes in. OpenShift Container Platform allows you to do the infrastructure services like scheduling, load balancing, registry. This is where Kubernetes comes in. It also allows you to do storage plugins and overlay networking administration. This is the infrastructure services to do clusters of containers, not just single hosts. How do you do lifecycle management of the container from development to staging and testing and staging into production? How do you do this with CI/CD, source-to-image capabilities, and across the full lifecycle? And then finally, I've already described the container management. CloudForms is included with OpenShift, and that's how we address this. In the world of microservices that I described earlier, where you have components that now need to get assembled together to represent an entire application, we are moving all Red Hat products into a container image so you can run our business rules management system, BRMS, as a container on OpenShift and use this capability to extend the application you have built. We have done the same with JBoss Fuse for integration. We've done the same for JBoss Data Grid, and we will continue to do this with our application platforms and other Red Hat products. We also work with our partners to help them move their applications into containers, and then we certify them and also put them in our registry as a certified application container. I will touch on a few things on the far right side of the chart. We also have other products that are also being enhanced and aimed at doing containers. Red Hat Satellite has the ability to do the host update management for Atomic Host. Today it's been traditionally used for Red Hat Enterprise Linux, but now it extends to also do the unique immutable infrastructure updates required for RHEL Atomic Host. We have software-defined storage offerings with Red Hat Ceph Storage and Red Hat Cluster Storage. One side note about Red Hat Cluster Storage is it allows you to attach persistent storage volumes to containerized applications. So most people think of containers as being appropriate for cloud-like stateless applications, but with Red Hat Gluster Storage, you can now consider how to do persistent storage for stateful applications with this storage volume. You can also think about how to architect high availability and failover into your application because of this capability. And then finally, a Red Hat registry. We ship a registry with OpenShift, but the Red Hat registry is a registry that we host on our customer portal and make available to our partners and to our customers to gain access to secure certified containers, addressing one of the problems that I mentioned earlier. So how do you begin? Well, one way to begin is to work with Red Hat on what we call discovery sessions. This is where we bring in our consulting and services teams, working with you in a very customized session using Red Hat methodologies to identify the business drivers for your use of the technology, and then to start looking at some of these technology challenges and also solutions. And finally, what's the action plan to move forward? This is one way to begin with us. I would like to talk about University of Technology in Sydney, one of our customers within this region of the world, although certainly Australia is a little far away from Korea. UTS has been using OpenShift to address many of their challenges around efficiency. Effectively, this is a DevOps case study. They today support 39,000 students and staff, and the IT organization there was very challenged because of these unique, complex configuration requirements that I mentioned earlier. They were also dealing with legacy data, virtual machines that they had to maintain, which were very big, very expensive, and very cumbersome. One example of this was they would do conferences and then videotape the conferences. They had to maintain these conferences on demand, or the videotaped sessions of these conferences on demand for sometimes years. And they did this with very complex, expensive, hosted, virtualized infrastructure. Well, they've now used OpenShift Container Platform to simplify their support of this. It gives the developers flexibility to do self-service, to use the current cutting-edge development tools, but it still provisions those to consistent standard infrastructure. It also allows them to take those video archives that I described and move them into lightweight containers that are much easier to store and retrieve than the virtual machines. So this is some of the key benefits that UTS saw. So to summarize, Red Hat is working very hard on your behalf as our customers to deliver containers to the enterprise, but this requires many different things that I've touched on. And I've only touched on them in a very high-level detail. A trusted host environment running on the leading enterprise Linux in the world. Comprehensive security across not only the host, but in the container, in the tools around it, in the registry, and the ability to set policy for security. Tools like OpenShift Container Platform that provide an integrated application lifecycle platform to develop these applications end-to-end, and then to manage them, delivering them faster and speeding up the efficiency of your company. Management tools to do all of this at scale across hundreds or thousands of servers. This is what Red Hat is working on, and we believe that these are the critical things required to deliver containers for the enterprise. So with that, I wanted to thank you very much for your attention. I look forward to seeing you through the rest of the day at the Red Hat Forum here, and I hope that other sessions are also equally enlightening for you. So thank you very much.